Hello everyone, my name is Jiahui. I'm from Zhejiang University of Technology. Today I will introduce something about my paper. The title of my paper is MS-BERT, a multi-layer self-distillation approach for BERT compression based on a smoothest distance. I will introduce my paper from the following 5 aspects. Next, I will introduce in detail. With the proposal of BERT, natural language processing has entered a new era. These transformer-based language models have achieved great success. However, the amount of BERT parameters is large, which seriously affects its efficiency and practicability. In the service industry, time and resources are often limited, which makes this language model hard to come into service. Based on the above questions, many existing studies of transformer-based language models have tried to accelerate inference speed and reduce the amount of calculation in various aspects. Knowledge distillation is the current general model compression method and has achieved good results. Self-distillation is a unique method of knowledge distillation. However, self-distillation also has certain limitations. First, the distillation process generally uses a specific teacher lawyer to guide the student lawyer. Second, the complexity of the sample is not considered. To solve the issues mentioned above, we propose a multi-layer self-distillation BERT based on a smoother distance. Next is the related work of this paper. The related work can be divided into 2 categories: knowledge distillation and self-distillation. The main idea of knowledge distillation is to train a complex teacher network to cultivate a compact student network to have considerable accuracy and efficiency. For example, TinyBERT proposed a 2-stage distillation framework, which performed transformer distillation during pre-training and fine-tuning. Lee proposed a many-to-many mapping for the BERT compression method, namely BERT AMD, which surpassed most methods in the accuracy of the model. However, knowledge distillation requires an additional small model whose performance depends entirely on the teacher model. Deploying additional models in the industry will cause a more significant burden. Moreover, the pre-training language model has proven to contain a lot of redundant calculations. Self-distillation is a unique method of knowledge distillation, whose students and teachers are in the same framework. Liu proposed a fast BERT model which combined simple adaptive mechanism and self-distillation for the first time. She proposed a method that combines self-distillation and self-ensemble to improve the performance of the model in the fine-tuning stage, but it didn't improve the inference speed. Different from the above method, we propose a self-distillation method to learn different levels of knowledge. Our model no longer requires additional external resources and avoids redundant calculations. In addition, it can effectively learn the knowledge contained in different layers of BERT for various natural language processing tasks. After introducing the related work, I will introduce my methods. The first is the overview of MS-BERT. We can see the overall architecture of the model in the figure. The main idea of MS-BERT is to transfer knowledge from different layers of BERT to the student classifier. Our model contains two parts, backbone and branch. The backbone is a BERT-based model released by Google. The branch part is mainly some student classifiers spliced behind transformers, which is mainly used to balance the prediction speed and performance of the model. Moreover, we propose a self-distillation method that utilizes the knowledge contained in all transformer blocks. Each student classifier in the branch learns from different layers of BERT. In this way, the rich knowledge learned by the 12-layer BERT model can fully transfer to student classifiers, and the performance of all student classifiers can further enhance. Next, we will introduce our method in detail. The first is self-distillation with a smoother distance. BERT encodes a wealth of hierarchical linguistic information. Different layers of BERT encode various levels of knowledge. Therefore, we designed a multi-layer knowledge extraction method based on a smoother distance. A smoother distance is a histogram similarity measure based on the efficiency of the transportation problem, and it is a linear programming problem that has been well solved. It extends the distance between individual elements to the distance between distributions. Our self-distillation method calculates the difference between the output distribution of all transformer blocks and the student classifiers. Then, we use it as the sum of transfer knowledge. Our goal is to reduce this difference to make the students more powerful. The second is student classifiers splicing strategy. Previous research directly spliced a student classifier behind each transformer layer without considering the complexity of different task symbols. In the process of adaptive inference, the model can exchange for higher efficiency by reducing the accuracy. However, in some experiments, the loss of accuracy is too large. A reasonable explanation is that different symbols have different levels of difficulty, and the more difficult symbols require a higher level transformer to be inferred correctly. The simple-wise adaptive inference mechanism will cause some complex symbols to be considered correct in advance and output prematurely, which leads to a decrease in overall performance. To alleviate this problem, we propose two splicing strategies for student classifiers, as shown in the figure. These two strategies allow the symbols to pass through more transformers before output to determine whether they are correct. In this way, the symbol can be more accurate before output. The third is top-key uncertainty. For an event or a piece of information, its uncertainty closely relates to the amount of information. For example, we need a lot of information to understand things that are unfamiliar to us. On the contrary, we only need a small amount of information for things we are familiar with. We can use channel entropy as a quantitative indicator of information content. However, for complex multi-category data sets, such as the symbol of a complaint ticket in the telecommunications industry, contain dozens of categories. Through the calculation of uncertainty, the uncertainty of almost every symbol is above 0.99. We randomly select 100 texts from the dataset and calculate their uncertainty. We can see from the figure that The uncertainty of almost all tests is close to 1. In this way, it is difficult to find a suitable trend to compare with the uncertainty, which causes the model to lose the ability of adaptive inference. To solve this problem, we propose the calculation method of top K uncertainty. In this way, we effectively reduce the uncertainty of the samples, thereby realizing simple-wise adaptive inference for complex data sets. Next is the experimental part. This paper mainly uses 4 data sets. The first 3 data sets are public data sets. Complaint classification data sets are real-world complaint texts collected from China Telecom. We divide the data set into 3 parts. The training set contains about 280,000 pieces of data, and the validation set and the test set each have about 90,000 pieces of data. We use accuracy and flops as the evaluation indicators of this paper. There are 3 baseline methods in this paper: BERT, BERT EMD, and FAST-BERT. We summarize the overall experimental results on the 4 data sets in Table 1. Compared with BERT-based, MS-BERT can speed up 2 to 12 times under different accuracy losses. We can adjust the speed of the model according to the tolerance for accuracy loss. Compared with BERT EMD, MS-BERT is slightly insufficient in accuracy. However, MS-BERT far surpasses BERT EMD in speed when the accuracy is not much different. Moreover, due to the fixed model structure of BERT EMD, there are a lot of redundant calculations. Redundant calculations make it unable to respond to changes in industry demand. On the contrary, MS-BERT can effectively reduce redundant calculations due to its adjustable speed. Compared with FAST-BERT, MS-BERT has improved accuracy on all datasets. Therefore, our model is more attractive in the industry. We also analyze different splicing strategies. The experimental results are shown in Table 2. The accuracy of 2 strategies improve to different degrees compared with FAST-BERT. We can choose different splicing strategies according to the actual situations of the industry. If the accuracy is more critical, we can choose the splicing strategy of the last key layers. Otherwise, we can choose the splicing strategy of every key layer. We also analyzed the key value. For different key values, the uncertainty of the samples is different. We randomly select a sample and calculate its uncertainty as k increases. It can be seen in the figure on the left that the larger the key values, the higher the uncertainty of the sample. We also randomly select 100 samples and calculate their uncertainty on the different key values. The figure on the right shows 3 different uncertainty curves. It can be proved that when the value of k decreases, the uncertainty decreases. When the dataset has a large number of categories, we can realize the adaptive inference of the samples by choosing the appropriate key value. Finally is the ablation study. From Table 3, we can find that after removing the multi-layer self-distillation, the model's accuracy rises slightly and the calculation amount of the model increases significantly. It shows that it is necessary to use EMD to measure the overall difference between teachers and students, and it plays a key role in reducing the amount of calculation of the model. After removing the splicing strategy, the model's accuracy decreases because the low-level student's classifier has output many errors in advance due to insufficient training depth. In summary, the two methods we propose are critical to the improvement of model performance. After introducing the experiment, we have summarized this paper. In this paper, we propose MS-BERT, a multi-layer self-distillation method based on a smoother distance. Our model allows each student classifier to learn from all teacher layers in the self-distillation stage, which can reduce the omission of knowledge. Experimental results conducted on 4 datasets show that our model has greater accuracy than FastBERT when the inference speed is similar. Compared with the traditional BERT-based model, it can accelerate 2 to 12 times under different accuracy losses. In industry, our model has strong practicability because of the adjustable inference speed. In the future, we will further study better knowledge transfer methods to improve the model's performance. The above is the content of my report. Thank you for listening.